everyone and Assalamu alaikum. I hope you are having a good day today. Well, I am here with my very first topic, which is trigonometry, and I have listed some formula for you which I am going to use in different kind of questions, and I will explain their application on different kind of question as I said earlier. So I'm starting with trigonometric ratios. As you can see, it is my screen. On my screen, it's my first and most important thing. First thing I will tell you about trigonometric ratio is that it is only applied on right angle triangle, right? As you can see, I have drawn a right angle triangle. Let me increase the size of this trigonometric ratio section. Okay, so as you can see, I have a triangle, right triangle, or right angle triangle. It has three vertices, A, B and C, right? And 90 degrees at A, right? So always remember that we have to label our diagram correctly. If you will not label it correctly, then our ratio fractions will be wrong, and according to this mistake we'll have a wrong solution in our question, right? So I'm going to tell you how to label your sides. See, in front of A, because A is of 90 degree, it is always hypotenuse, so hypotenuse will always face towards 90 degree, right? And suppose we have angle X given at vertex B, right? Then the side opposite to it will be referred to as opposite. Some people call it perpendicular as well, but it doesn't make any difference. Perpendicular and opposite is the same thing, right? Similarly, the side along with AB, where I'm moving the mouse pointer, it is called as adjacent, and I told you earlier that opposite to 90 it is always hypotenuse. Also hypotenuse is the longest line, right? So that is the explanation of the triangle. Right angle triangle is only used in trigonometric ratio, okay? No other kind of triangles. Then our first trigonometric ratio is sine x, normally written as sin and x, and read as sine x, right? The formula is opposite over hypotenuse, okay? So this is our first trigonometric ratio. Sine x is equal to opposite over hypotenuse. Similarly, second one is cos x, which is adjacent over hypotenuse. Adjacent is the side along with the angle given, right? It is along with the angle given plus 90 degree. And then we have third, tangent x, normally written as tan x. So it is opposite over adjacent. I have written their short forms as well that you can memorize easily. So, ka and toa, right? Like if you want to use sine, you must know so. So means S is for sine, O is for opposite, H is for hypotenuse. Similarly, ka, C is for cos, ya cosine, A is for adjacent, and H is for hypotenuse, okay? And toa, T stands for tangent or tan, O for opposite, and A for adjacent, right? So this is how we memorize trigonometric ratio. Along with these three trigonometric ratio, we can also apply Pythagoras Theorem, which is applied on 90 degree triangle, right? It is simply hypotenuse square is equal to adjacent square plus opposite square. It's a very common formula for finding the length, right? Ratios are used when one angle is given and one side is given and other sides you need to find. Then we can apply sine x, cos x or tan x according to the situation given. But Pythagoras theorem is only used when two sides are given and third side you are going to find, right? So Pythagoras is applied only for the sides, but with the help of ratio we can find the missing angle or missing sides both, right? So this is trigonometric ratio. After that I will come to Sine Rule, which is another important formula. You can see on the screen. Let me bring it in the center. Okay. Now Sine Rule I am going to discuss with you. It is applied on any other kind of triangle which is not right angle. Whenever it is right angle, you are using trigonometric ratios, right? Okay, so in sine rule I am making a triangle here. As you can see, it's a triangle. You must know the rule of labeling the sides. Like I have three vertices of the triangle A, B and C. The side opposite to vertex A will be labeled with A, and the side opposite to vertex B is B and small b. You are looking at the screen that I am writing small letters, right? And side opposite to vertex C is labeled as small c, right? So that's how we label the triangle, and you can see it here as well in this diagram. Now if you need to apply the formula sine rule for sides, the formula is a over sine A is equal to b over sine B is equal to c over sine C. Now these are the angles actually which are written with sine, and A, B and C, smaller ABC, are the length of the sides. Okay, the same formula is modified if you need to find the angles. It's just a reciprocal of this basic formula. It is the base formula, and for finding the angle I'll just take the reciprocal of all the fractions. It will be sine A over A is equal to sine B over B is equal to sine C over C, right? So that this is the formula. I will use it in the question, then you will know how to apply that, right? Right now I'm just telling you about the formulas which are going to be used in the questions. Then again, in the sine rule or the sine, we have another formula for area of triangle, which is 1 over 2 A B sine C. Remember that A, B are the lengths of the side. Okay, well, I will tell you that how to memorize this formula. A, B sine C is not a fixed formula. A means first given side, B means second given side, and C means their included angle. Like if you are having the value of A is equal to 5 and value of B is equal to 7, then you must have the angle value of C, suppose it is 30, right? Then you can find the area of the triangle. Included angle means the angle given between two sides, two given sides. Okay, so this is 1 over 2 A B sine C. I always tell my student that memorize it as 1 over 2 into first given side into second given side into sine of included angle. Whatever angle is included between the included with the given sides, or which is in between two given sides, we will use that angle only, right? If any other angle is given, then you cannot apply this formula. First you need to find their included angle, the given side included angles, right? Okay, so now I'm going to tell you about the relation between acute and obtuse angle of sine and cosine, right? Now first of all we need to understand what is acute and what is obtuse angle of sine and cosine. Suppose we have a triangle like that. I'm making a new triangle for you. The vertices are again A, B and C. Okay, so if I extend this line side AB, if I produce it to another point D for example, then the angle inside the triangle right now is acute angle. So X is acute, and this outside angle of the triangle, suppose it is Y, it is obtuse. Okay, this is acute and obtuse. So you can easily understand that both angles are on the straight line, so their sum will be of 180 degree. So if you have X value is 60, if X is equal to 60, then Y is equal to 180 minus 60 equals to 120. Now you see acute angle is always less than 90 and obtuse angle is between 90 to 180, right? 90 and 180 are the bounds. In between these two boundaries you can say we have obtuse angles, and any angle which is greater than 180 will be called as reflex angle. So obtuse, acute and reflex angles. 90 degree angle is always right angle, right? So these are the name of the angles. Okay, So I'm erasing it, acute and obtuse, because the diagram is already there, so I'm erasing it. Okay. So the relation between acute and obtuse angle, as you can see on your screen, sine A is equal to sine 180 minus A. It means that sine 60 is always equal to sine 180 minus 60. I hope you can understand my writing. It's a bit difficult for in the beginning to write on this tab. Anyways, so you can say sine 60 is equal to sine 120, and you can use your calculator to verify that whatever value you get for sine 60, you will also get it for sine 120. Okay, so the formula is sine A is equal to sine 180 minus A. It is exactly same, right? So whatever answer you get for sine 60, you will also get it for 120. In cos, we have a difference. It is cos A is equal to minus or negative cos 180 minus A. It means that cos 60 will always be equal to minus cos 180 minus 60, which is 120. I'm just straight away writing that angle, right? So whatever value you get for sine 60 on your calculator, your cos 120 will be the same, but the sign will be negative. So it will be additive inverse of the cos 60 angle. Okay, additive inverse, the sign will be changed. So these are two relations between sine A and cos A. Their sine and cosines obtuse and acute angles. We will use it in question, of course. And similarly, we are on the last thing in this topic is cosine rule or cos rule. Okay, I have made another triangle with 3 vertices. It's a different triangle, not similar to the previous ones, but it is not a 90-degree triangle, right? So it is a standard triangle. If you need to find the sides for by using the cos rule, then your formula will be a square is equal to b square plus c square minus 2bc cos A. Now how to memorize it? A is unknown side, B is first given side, C is second given side, then minus 2 into first given side into second given side into cos of A. A is the angle opposite to the unknown side. You see that? A and A. If you are finding A, then you need this angle, right? If you are finding B, then you will use this B angle. Okay, and if you are finding C, then you will use C angle in the formula. As you can see, I have written all 3 situations. For A square, it is b square plus c square minus 2bc cos A, and if we are finding B, then b square is equal to a square plus c square minus 2ac cos B, and c square is equal to a square plus b square minus 2ab cos C. Of course, we have to take square root for finding the final answer of the side that you can include in your last step of this type of question. Okay, so this is the formula for sides. If you need to find the side with the help of cos rule, I will tell you when to apply sine rule and when to apply cos rule. But if you need to find angles, you can use same formula as well, but the formula is changed. You can apply this one directly. Cos A is equal to b square plus c square minus a square over 2bc, and cos B is equal to a square plus c square minus b square over 2ac, and cos C is equal to a square plus b square minus c square over 2ab. On this side we have angles. A, B and C are the angles, while on this side we have sides. So whenever all 3 sides are given and you need to find one angle, you will go for cos rule and you will apply this formula, one of this formula according to the situation given. Okay, right. So these are the formulas which we are going to use in our questions. I have selected some questions. Let me find first question. Suppose we are going to solve this question. Let's have a look. I have hidden the formulas. I will tell you how to apply, how to understand the question first. In the figure, angle ADC is equal to angle ACB, and both are 90 degree. You can see on the diagram as well. ADC, now ADC, so angle will be at D, right? The center label will have the angle. Similarly, ACB means the angle will be at C. So you can see both are 90 degree. Similarly, AED, angle is given equal to 55.1. It is also given in the diagram, 55.1. Okay. ACAB angle is 40.4. 40.4 you can see on the diagram as well. AE side is 4.1, AD side is 3.7, and AC side is 8 centimeter, right? So all the values, all the figures you can see on the diagram. Diagram is fully prepared. The first thing you need to find is angle ACD. Now let's work out for ACD. The first thing, you must mark that angle whatever you are finding. I am finding ACD angle, this one, right? And it is included in the triangle named ADC. If I make a separate diagram for ADC, I have taken this triangle out with label A, B, sorry, it's A and D and C. Okay, you have the lengths given. This side is 3.7 and this side is 8.0. You can see on the diagram AC is 8.0. I have written it here, and I need to find ACD angle, and we have a 90 degree and D, so it's a right angle triangle, so I am going for trigonometric ratio. Now I need to decide out of 3 sine I have 3 ratios: sine, cos or tan. Now I need to check which one is applicable here, right? If this angle is unknown, like C, say it is x, for example, then the side opposite to this angle is called as opposite. Okay, and this 8 centimeter is opposite to 90 degree, so it is hypotenuse. Okay, now you must understand which formula is going to be used. I am using that again, same, so ka and dua. So sine is equal to opposite over hypotenuse. Because I have opposite and hypotenuse, so I am going with sine. So my first part, A part solution, is sine x, or you can write the full name of the angle. Let's write the full name. ACD angle is equal to opposite over hypotenuse means 3.7 over 8.0. Okay, then you will use your calculator, but first you make another step. Angle ACD is equal to, when I take this sine to the other side, it will become sine inverse, so it is 3.7 over 8.0. Now you will use your calculator to find the answer. Okay, so you will use your calculator from here, and angle ACD is equal to 27.5. In Cambridge, your final answer for angle should be corrected to 3 significant figure, or you can say 1 decimal place. Okay, in case of angle only. So that's how we'll be finding ACD angle. Similarly, for second part, you need to find the length of AB. Now I will see in which triangle I have AB. AB is included in this triangle ABC. You can make it you can take it in a separate diagram, but you can do it as it is as well, but just for understanding I am making another triangle, and I am making it in a straight manner. It's C point. Here we have a 90 degree. It's B and it's A. Now I need to check what is given. This angle is given equal to, angle at A is 40.4. Similarly, and the length AC is given 8.0. You see, I have just rotated this triangle in a straight triangle so that we can easily understand. And we need to find the length of AB. Now, I think you have guessed it, that we need to find hypotenuse, and because angle is here, so this side will be the adjacent side. Okay, adjacent. So adjacent over hypotenuse, you can see it's cos 40.4 is equal to 8.0 over x, and then you will make a cross multiplication. X is equal to 8. 8.0 can be written as 8 only over cos 40.4. Again, you will use calculator for this answer. So I am using my calculator to find the final answer. You can use your calculator and check the answer. Make sure your calculator is in degree mode. Sometimes the mode is changed and we are getting wrong answers. Basically not wrong answers, but those answers are calculated with different standard of angles. Sorry, it's a side, so it's a centimeter. So that was B part of the same question. Now for the last part, it's area of triangle AED. Now AED is this smaller triangle on this left side of the diagram. If I make it in a separate diagram, it will look like this. The A vertex, then E vertex, and then D vertex, right? This angle is 55.1, and then I have the length of AE, which is 4.1, and AD, which is 3.7. Okay, because the triangle is not right angle, so I will use sine's area formula. Area of triangle AED is equal to 1 over 2. As I said, first given side, it is 4.1 into second given side, which is 3.7, and sine the included angle, which is 55.1. Again, you will type the whole expression on the calculator to get your final answer. I am using my calculator. In one video I'll explain the use of calculator as well, but I hope you are all familiar with it. Okay, so we are using calculator. It's 1 over 2 into 4.1 into 3.7 into sine 55.1. Okay, and you will press equal. The answer on my calculator screen is 6.22, and because it is area, so your unit should be centimeter square or square centimeter. Okay, so that is how we will be solving such kind of question. You see, in one question we use trigonometric ratio, we use trigonometric ratio for angle, and similarly in the same question we found the area of triangle. Okay, so always in Cambridge exam you will have a mixed question, so never focus on one single topic. Now I have another question. in which we'll be using sine and cos rule, I guess. Now this is the question. The figure shows the cross section of the roof of an old cottage. It is given that AP is 5 centimeter and 5 meter, and PC is 8 meter, and angle APC is 60 degree, and ABC is 45. Everything is drawn on the diagram. First thing, you need to find the length of AB. Now AB is here in this triangle, which is it is in the bigger triangle as well, but the required things are in ABP triangle. Okay, so we are going to make the triangle APB in a separate triangle. I hope I'll draw it correctly. Now I will label it A. This is A vertex, this is B, and this is P. Okay, also I'm extending this line because I have this angle in the question, which is 60 degree. Okay, plus this side is 5 meter and this angle is 45. Okay, I need to find this angle because in sine rule we have to find the angle. We must have angle opposite to the unknown side so that we can find that unknown side. Okay, so first step is finding A P B angle. Okay, so it is 180 minus 60 because these two angles are on a straight line, so their sum is 180. So the answer for this angle is 120 degree. Now this angle is 120. Now I will use sine rule because I have this 5 meter line and angle opposite to it is 45. Also I need to find AB and I have the angle opposite to it, right? So I'm using it as AB side over sine B in this case. Sine 120 equals to 5 over sine 45 because in front of this 5 meter line we have 45 degree angle. Okay, then a simple cross multiplication. It is 5 multiplied by sine 120, and again you will use your calculator. Let me use my calculator. It's 5 multiplied by sine 120. The answer is 4.33. right? And the second thing that you need to find is the length of AC. Now AC is in this bigger triangle, and you see it is included in APC triangle. Okay, I will draw this triangle separately to explain. It's triangle A, B and C. I have PC 8 meter, I have AP 5 meter, and angle at P is 60 degree. Because I have two sides given and unknown side has angle opposite to it equal to 60 degrees, so this is for cos rule. And check how I am applying the formula. I'm solving it here. It's AC square equals to 8 square means first given side plus 5 square which is second given side minus 2 into 8 into 5 into cos of angle opposite to AC, which is 60. Right, again you will, it is 64 plus 25 minus 2 into 8, 16, 16 5s are 80 and cos 60. Now from here let me tell you the important thing. You will solve this expression separately and these two separately, and then you will subtract your answer. Be careful with this calculation. Many students make it wrong, and they get, after doing everything correct, they get the wrong answer, right? So 64 plus 25 will give you 89 minus sign, then 80 multiplied by cos 60. It's 40. So when you will subtract, your answer is 49. It is the answer of AC square. I told you to take square root in the end, in the final step. So AC is equal to 7. Okay, so that's how we'll be using sine rule. This is the example of sine rule, and this is an example of cos rule. Okay, so in one single question you have seen the application of sine and cos. Also in previous question we used trigonometric ratios along with the area of triangle formula. Okay, so I'll be solving some more questions. If you need to ask anything or any specific question or anything, you can post in comment. I'll tell you how to send your question to me, and in next video I'll be discussing some more questions, some more examples of these formulas. I hope till then you will make good practice of these formulas, and also I will include the bearing and three-dimensional trigonometry in my next video, right? Wait for that video. I hope this current video which we have just seen will be helpful for you. I'll see you in next video with some more question of trigonometry along with the bearing and the three-dimensional trigonometry. Till then, take care. Allah Hafiz, and do mathematics properly and happily. Allah Hafiz everyone. Take care.